Today we're going to complete the 7-day 16 notes on solving logarithms. I would like for you to pause the video at this time and complete the 4-question warm-up. Do your best. If you don't know how to answer a question, I'll talk about each of these in just a moment when you restart the video. Welcome back. I really hope you pause the video because if not, I sound really lame, but that's okay. So for the first question of the warm-up, you were asked to evaluate. Remember, we want to do that circle of life. 3 to what power is 9? Even though it is 3 times 3, remember that on the right-hand side of the equals, that is the power you raise 3 to get to that value of 9. Now, if you got part A right, I hope that you got part B because all you had to do was make that exponent negative. If you ever want the reciprocal value, so cover up that 1. Like sometimes I'll put up my finger over that 1 and think 3 to what power is 9, and then make the reciprocal value by making it negative. Part C was very tricky. So if you got this right, you can pat yourself on the back as I'm talking about the answer. This has no solution. 3 to some power equaling negative 9 isn't possible. 3 to the second power is 9, but you can't put in a negative 2 to make it a negative 9 because as we just saw, putting in a negative 2 makes it the reciprocal. There is no possible way you can take a base that's positive and raise it to any exponent to get a negative number as a result. Also tricky, part D. If you got this one right, also give yourself a pat on the back, maybe on the other side to give it some symmetry there. Why is this not possible? Because think about it. If you sub in, first of all, positive exponents on part A, you get bigger numbers. If you sub in negative exponents, you get smaller numbers. But no matter how small of a negative exponent you put in there, put negative 100, it's still not going to get to 0. Remember that when we graph exponential functions, if I said graph 3 to the x, remember that when you graph 3 to the x, I'm going to do a quick sketch here, you're going to have a horizontal asymptote here, and your graph is never going to hit that value. So as a result, you're going to see that because this can never equal 0, there's no exponent that you can raise 3 to equal 0. Even raising it to the 0 power, remember anything to the 0 power equals 1 wouldn't work. So let me know if you have any questions on the warm-up. But what we're going to do is get into the next part of the notes for today. So in conclusion, if you are looking at the argument of a log, my dog is cleaning himself right now. If you look at the argument of a log, what is the argument? Remember the argument is this number right here. So the 9, the 1/9, the negative 9, and the 0. That number must always be positive. Now, when I say positive, I mean 9, 1/9. Negative 9 obviously doesn't work, and 0 also does not work. 0 is not considered a positive number. Remember, 0 takes on no sign. So when we talk about the argument of a log, it has to be a positive number. And I'll even put in parentheses here just so you know it can't be 0 or negative. Just so you really understand what that word positive means. Now, as a result, when we solve log equations, you're going to have to check your answers because you may get an answer that when you sub it back in is what we call an extraneous solution because it does make the argument negative or equal to 0. So what do I mean by this? Let me show you how this is done. You're going to get a problem like part A where it says solve this log equation. And wow, does this look scary. But before you get too confused and caught up into what this is saying, I want you guys to think about how we solve problems when I give you 3 to some power equaling 3 to another power. Remember that when you have the same base, all we have to do is set the exponents equal to each other. Well, think about what part A is saying. If you have a log with a base of 4 on one side and it has some argument, and you have a log with a base of 4 on the other side with some argument, if this is the same, the log and the base are the same on each side, then to solve this, all you have to do is set this equal to this and solve for x, just like you would do if this was exponential. So with that being said, we're going to take this x plus 3 and we're going to set it equal to the 8x plus 17, and we are going to solve for x. So it doesn't matter which side you move the x's to. I'll move mine to the right. I know some of you don't feel comfortable with that. I get it. And then we can subtract the 17. So then what I get is negative 14 equals 7x. And then I could divide by 7 to get negative 2 equals x. Now, before you box this answer and say all is good in your hood, you need to make sure this is not an extraneous solution. You're going to take the number you just got and you're going to sub it back in to the original equation. It has to be the original. And you're going to sub it in for the x's. If it makes the log's argument negative or 0, it's not a valid solution. Notice if I put a negative 2 here and I add 3, I get a 1. That's positive. We're all good. If I add a negative 2 here, I get a negative 16 plus 17. I get a 1. Also good. And notice that works. These two sides would be equal. Actually, 4 to what power equals 1? That's 0. You would get 0 equals 0, which works. So you are getting that the solution of negative 2 does in fact work for this. Now, same thing with part B. Just set those arguments equal to each other. Oh, hello. Where are we going? So what you're going to do is you're going to take this and set it equal to that, and then just solve. We get x minus 9 equals 3x minus 13. We can move the x's to one side, and then we can move the numbers to the other side. Now you get the solution, and sometimes people miss this because they're like, oh, x equals 2, it's a positive number. But remember, that's not what matters. What matters is that when we sub that value in, does it make the log's argument negative? So notice if I do 2 minus 9, it's negative 7. That's not okay. You can't have a negative inside of the arguments, or you can't have a negative for the argument because it will be an extraneous solution. So this right here would have no solution. So notice how I only checked the first log. If I had checked the first one and it was positive, I would then have to check the second one to check for that being negative. But if it breaks the machine for one, it's not going to work for the other, or it doesn't matter if it works for the other. Now, what I ask that you guys do is at this time, pause the video and complete the you try on your own. We're back again. So for this one, you should have set the 2x minus 10 equal to the x minus 6. When you brought the x's to one side, you should have gotten x. And then when you brought the numbers to the other side equals 4. And then when you sub that in, notice here, you're getting 2 times 4, 8, minus 10. This whole argument becomes negative 2. No good. Even though it does make the other argument negative 2. I don't know if any of you checked that. It doesn't matter if it makes the two sides equal. If it does not keep the argument positive, then it's an extraneous solution. So here's another one that would be no solution. So we're going to go to the next set of examples where we don't have logs on each side. We still have a log in the equation, but we only have one log. So if you're looking at example 2, part A, and a problem like this, think about how the warm-up started, where I said to solve and you had to use the circle of life. If you ever have one log, you're just going to do the circle of life to solve this. We don't like the logs, right? Let's get rid of them. And the first set of problems, how did we get rid of them? Well, because we had the same base on each side, we could. For these problems, to get rid of the log, we're going to do the circle of life. So I'm going to get that 4 squared equals x plus 3, or 16 equals x plus 3. And when I solve for x, I'm getting 13 equals x. Now, before you submit that answer, make sure you check it. If I sub in a 13, it does in fact make that log positive. In fact, it makes it a 16, and that does check. 4 to the second power does equal 16. So it's kind of cool. You could check as you go. Same thing with this next problem. We need to isolate the log. Like always when solving, you want to isolate that expression that has x. So what I'm going to do is I'm going to isolate that term that has x, We're going to subtract the 1. And then from here, you may say, well, I want to get x alone. Remember that we're going to use the circle of life to get rid of the log. You can't divide the log. Like, these are super glued together. So don't think that you could just divide the log and that's your answer. In order to get rid of it, we use the circle of life. Now, you should remember that if there's no little number here for the base, remember my little strategy that it looks like a 10? You're going to put a 10 here and then do the circle of life. So interestingly, I get 10 squared equals x, and then I just get 100 equals x. Now check it. If I sub that back in, we're all good. When you sub in that 10 there, you will in fact get a positive number in the argument. And then finally, the last one in the set, you are going to, again, isolate this term that has log. Now we have to get rid of 2 numbers. One number we have to get rid of by addition. So 2 log base 2x equaling 10. The other number we have to use division. So I get log base 2x equaling 5. Then we can do the circle of life. So we get 2 to the 5th equals x, and that, I believe, is 32. Check your answer. Note that if I sub in that 32, I am all good. You could even check further, by doing the circle of life. 2 to what power is 32? It's 5. And then if I did 2 times 5 minus 4, notice that does give me 6. So that's that set of problems. The final set of problems involves using the properties. So I did not know that. So the final set involves using the properties to condense before solving. So let's talk about each set. First set, we had logs on each side. We could set those arguments equal to each other. Second set, we only had 1 log. So we had to use the circle of life to rewrite it and get rid of the log. On this set, this is kind of like if I give you guys a problem where it's like 3 to the x power times 3 to the x plus 2 power equals 3 to the 5th power. Remember that when we did these problems, we had to combine these with the properties first. And remember, we had to add those exponents, and then we could set them equal. Sorry, I know I did the problem in reverse, but the whole idea was combining those 2 into 1 using the properties, and then we can do what we did with setting them equal. Well, that's exactly what we have to do here. But unfortunately, the properties of logs look a little different, and it's actually what you've been practicing the last 2 days. If you see a plus sign in between the 2 logs, remember that that means to make the product of the arguments. So I'm going to condense these 2 logs into 1 log by rewriting this as log base 3, and then I'm going to do the product of 4 and x plus 1. That's going to equal the other side. Now, if you understand that, you can kind of see where we're going from here, because once you have a log on each side, we're going to be able to set the arguments equal and solve. But before we do, let's just clean up what's inside that argument. I'm going to distribute the 4 and make this 4x plus 4. Now, 1 log on the left, 1 log on the right. It's the same idea as if we had something set up like this, where we have the same base on each side. Let's set those arguments equal to each other. So then we can get the x's on one side. I'll actually subtract the 4x just to keep x positive. Not that it matters. And then add the 3 to get the 7. Now, these can have extraneous solutions as well. Notice that the first log I'm all good with, because this first log has no x in there. It has a 4 for the argument. It's already positive. Second log, if I fill in a 7, notice that it makes the argument 8. We're all good. And then over here, if I fill in a 7, that's going to keep it positive as well. So this answer does in fact work. And then the final problem for today, and then I'm going to give you a few to try on your own. Same thing. I see a plus sign in between the 2 logs. So what I'm going to do is I'm going to use my properties to condense this into 1 log. One log to rule them all. It's a Lord of the Rings joke. So I'm going to get log base 6 and then make that product of 8 and the x minus 2. Now, like I did on the last problem, let's simplify that argument by distributing to get 8x minus 16. Now, be careful. Do not, big mistake. I see it all the time in pre-calculus. Just take that 8x minus 16 and set it equal to 2. We have two different types of log problems. One, where you have a log on each side. You set the arguments equal. But the other type is if you only have one log, we use the circle of life. So on this problem here, we are not going to say 8x minus 16 equals 2. We're going to do the circle of life, and we're going to say that 6 squared equals 8x minus 16, and then solve that. So get 36 equals 8x minus 16, add the 16, so it's 12, carry the 1, 3, 4, 5. I feel like my math is wrong, and I've really, 12 carry the 1, no, maybe not, because that wouldn't work. That's right. I guess I'll go with it. I mean, there's nothing wrong with getting a decimal. I hope I'm not wrong. If I am wrong, I'll come back and I'll write a note. But my math all checks. I mean, I'm not catching anything in my math that would be wrong. So, yeah, it's good. 36 plus the 16. Yeah, we're good. So we'll just get that answer. It'll be a decimal, but that's okay. Decimals are okay. I mean, really, they are. I just caught me off guard that I was getting one. So we got 6.5 equals x. So if you sub that back in, notice that does in fact give us positive values inside of the logs. So we are all good. At this time, I would like for you to pause the video and complete the U-try, and I'll go over those answers as soon as you are done. All right, let's see how you did. So for the first one, you should have done the circle of life, gotten 3 to the 4th equals x plus 7, 81 equals x plus 7, subtract that 7, and you get an answer of 74, and it does in fact work. For part B, also only one log, so you had to isolate it by adding 1, then do the circle of life. You get 2 to the 6th equals x, and then x equals 64, also works. And then with this last one here, there is a plus sign between the two logs, so we have to make the product of the 4 and the x minus 7. Remember that there was a base of 10, so when you do the circle of life, you can then go through and solve and get a value of 32. And again, it does keep that second log. When you sub it in for the x, it does keep it positive, so we're all good. And then the challenge, I really hope you guys tried this challenge. A lot of our questions in pre-calc look like this. With the challenge, you had to multiply the x with the x plus 5, and we get a quadratic in the argument. When you do that circle of life, you do have to solve by factoring, and when you get the two solutions, you should have noted that one of those solutions did not work. That -9 makes actually both of those logs arguments negative. The 4, however, did work. So hopefully you tried this one out and hopefully you got it right. And if you did, great job, because a lot of the problems we do in pre-calculus look just like this.